So picking up where we left off, we want to take this vehicle model that we have and generate a top-level architecture that we could then import and use in the workflows in Amber. One thing that we want to keep in mind when developing the top-level architecture is that the assumption is on the top level we only have buses that are connecting the component model, so that we can actually see here that each one of these signals that are connecting the block, say from the engine to the driver, these signals are actually numeric signals. So we have vehicle speed, we have the maximum torque possible for the engine, we have the minimum torque from the engine, or the brake torque, closed throttle torque. So because of that, we have these numeric signals that are being passed between the component models, and we actually want to have bus signals that are passed between the component models. So what we'll have to do is modify this top-level diagram so that we're exchanging bus signals between the components. So what I'll do is you could either start with this diagram, or we could start with a new one and just add some subsystems. And I'll just use the names that we have in the previous diagram. So we'll have a driver, we'll have an engine block, we'll have a transmission, so we have driver, engine, transmission, then we'll add a driveline and a chassis block. And then finally a chassis. So then what we'll do is we will take the output from each one of these blocks and send it as a bus to a top-level output. And then we'll make sure we take all the inputs in and then send that single bus input to each one of those blocks. That way we can exchange any signal to any one of the blocks. So I'll do that with some go-to from blocks. And I'll label this driver bus. And I'll do the same for each one of these other blocks. I'll rename this engine. Rename this transmission. Name this driveline. And I'll rename this chassis. We'll make sure each one of these labels is correct. So that says driver bus out. So we want to say engine bus out. So I'll just copy a name and make that the go-to tag. Transmission, the same, I'll make this the go-to tag. Driveline bus out. And then chassis bus out. Okay, and then here I will make a bus creator and an out port. And we have 1, 2, 3, 4, 5. 5 signals, so I'll make this 5. And then I'll add from blocks with the corresponding label. Move this down. We'll make this a little larger. So this is the engine bus. Transmission bus. And the driveline bus. And then finally the chassis bus. Then we connect each one of these signals up to the bus creator. Then we also have an import. So with the import, we'll have a input bus. So I'll create another go-to. This one I'll call it main info bus. And then I'll connect a from block to each of these components. And then I'll make sure the tag is placed here. Okay, so we can see those are all linked. Driver bus out goes to driver bus out. Engine bus out goes to engine bus out. Transmission bus out goes to transmission bus out. Driveline bus out goes to driveline bus out. And then chassis bus out goes to chassis bus out. Okay, so that creates the Simulink top level powertrain architecture for this model. Now we still have to add the line annotations on each one of the signals so that when the configuration is captured, the user interface recognizes the properties of each of these as a bus. So we have to mark that information on each one of these lines. So we use these special annotations. So you put square brackets and with the square brackets, you could zoom in. And on the square brackets, what the information that we put is we put the bus name, comma, then the type, and then if it's GUI visible, I'll just mark that as false. So the bus name is driver bus out. The type is bus, and we'll just make it GUI visible false. So we won't show this connection in the user interface. If connections are being made between the blocks directly, sometimes it's actually nicer to have GUI visible set to true. That way in the user interface you could see those connections connecting two different blocks together. But in this case, because we're routing all of the connections to the parent level and then bringing in all the connections to the parent level, the connectivity isn't as interesting. Here's the engine. And we have transmission. And we have driveline. And then finally, we have chassis. So I'll zoom out. And for completeness, we'll just put the annotations on the go-to signals. So those are all the output annotations, and then we'll do that for the input. So this is the main info bus. And I'll also put the annotation here. We'll zoom in and just inspect the annotations. We could say the bus name is main info bus, comma, type is bus, and then comma, GUI visible is equal to false. In this case, all the connections are bus connections. There are two other types of connections that one could use that are derived from bond graph methodology, where you have an effort and flow. So in some of the powertrains for autonomy, you'll see that convention where a torque is being sent from the engine to the transmission, and then a torque is being sent from the transmission down the length of the drivetrain to the wheels and the chassis, where the speed is computed, and then that speed is fed backwards to the components as a flow. So sometimes you'll see an effort and flow pair that will be used. But in this case, we'll just use the bus type and then send those information from each block to the standard single output bus, aggregate them together, and then bring those signals back in, and then make those signals available to all the components. So in the next step, that finishes the work that we're doing in Simulink for creating the powertrain architecture. There is one more block that we could create, a very simple block on the top level, just to wrap the bus around. So this output bus is then fed back around to the input bus. We'll do that in the next video, and then we will split up the M file that initializes the vehicle into component initialization files, and then we'll proceed from there to start importing the component models and calibration data.